All right, today we're going to dive deep into the architecture of Cisco Umbrella's Secure Internet Gateway, or what you'll often hear called SIG. We're going to break down how this single cloud-based service can really simplify your network, slash your risk, and most importantly, secure access for all your users, no matter if they're in the office or on the other side of the planet.
So here's our game plan. First, we'll talk about the huge challenge security teams are facing right now. From there, we'll actually build up our defense, layer by layer. We'll start with governance and DNS security, then we'll move into deep traffic inspection and threat isolation, and finally, we'll tie it all together with a cloud-delivered firewall. Let's jump in.
Okay, so to really get why a secure internet gateway is such a game changer, we have to start with the problem it's built to solve. You know, the old way of working is basically gone, which means the old way of doing security has to go with it.
Just think about how it used to be. Every single user, no matter what branch office they were in, had all their internet traffic funneled all the way back to headquarters for security checks. In a world where everyone is using cloud apps like Office 365 or Salesforce, that's just a recipe for terrible performance and unhappy users. The modern fix is an architecture called SASE, Secure Access Service Edge. It completely flips the script by putting both your networking and your security in the cloud, right next to the users and the apps they need to get to.
And this visual just perfectly illustrates how SASE works. It basically becomes this smart, secure broker up in the cloud. So instead of users connecting back to the mothership, they connect directly and securely through this SASE cloud, wherever they are. It's security and connectivity, all delivered as one simple service.
So, this brings us to one of the most fundamental rules in all of security. You just can't protect what you can't see. Before we can even dream about applying policies and blocking threats, we first have to get a handle on all the cloud applications our users are hitting, the ones we know about, and maybe more importantly, the ones we don't.
And here we go. This is a look right inside the Umbrella dashboard at the App Discovery Report. This is where you get that mission-critical visibility. You can see every single cloud app in use, flag the ones that might be risky or go against company policy, and start making really smart decisions. It's how you finally shine a bright light on all that shadow IT.
Now, visibility is just the first step. What we really want is control. And that means building a really strong security posture on a few core principles. You enforce minimal privilege, so people only get access to what they absolutely need to do their job. You use provisioned access, not static passwords that can be stolen and reused. And of course, you make things like MRFA and strong password policies totally non-negotiable for every single account.
It's really important to see that these aren't just random rules on a checklist. They are all pieces of a much bigger cloud governance framework. Think of this as the strategic layer that makes sure your security policies are actually helping the business, ensuring that from setting standards to running audits, you're always managing risk the right way.
Okay, so we've got our governance framework in place. Now we can build our very first active layer of defense. And for Cisco Umbrella, it all starts at the most fundamental level of how the internet works, the domain name system, or DNS.
The idea here is so simple, but so incredibly powerful. Think of DNS as the internet's phone book. Before your computer can connect to a malicious website, it has to ask DNS for its address first. Well, Umbrella steps in right at that moment. If the address belongs to a known threat, Umbrella just says, nope, not going to give it to you, and the connection is stopped before it ever begins.
You can see the whole flow right here. A device makes a request, it gets sent to the Umbrella cloud for a super fast check. Safe requests, you see them in green, they get passed right through. But the malicious requests in red, they are stopped dead in their tracks. This is your absolute first line of defense against things like malware, ransomware, and phishing.
And the impact here is huge. I mean, deployment is unbelievably fast. You can often protect an entire organization in minutes. It covers every device, even the weird IoT stuff on your network. But one of the biggest wins is for your security team. By blocking all these threats so early, you dramatically cut down on the number of alerts your other tools have to deal with, which is a huge help in fighting that constant alert fatigue.
So DNS security is amazing for blocking destinations we know are bad. But what about websites that are just kind of suspicious? Or maybe they're brand new and we don't know anything about them yet. Well, for those, we need to go a level deeper. And that is the job of the Secure Web Gateway, or SWG. You can think of the SWAG as an intelligent security checkpoint for all your web traffic. Because it acts as a full proxy, it can actually open up the data packets and look inside, even when the traffic is encrypted with HTTPS. This lets it find much more advanced threats, block risky file downloads, and give you really fine-grained control over what your users can and can't do online.
And right here, you can see the core functions of the SWG. You've got visibility tools like URL logging.
You have control features for different apps and content categories. And critically, it includes SSL decryption to see inside that encrypted traffic, and it also integrates file inspection and sandboxing, which can basically detonate a suspicious file in a safe, isolated environment to see if it's hiding malware.
But what about the absolute riskiest situations? Let's say you have a security researcher who needs to go to a potentially malicious website as part of their job. You can't just block them, but you absolutely can't risk their machine getting compromised. The answer for this is an incredibly powerful technique called threat isolation.
This visual shows you exactly how this magic works. On the left, without isolation, the user's browser is directly executing all that potentially dangerous code from the website. But with remote browser isolation, or RBI, you create what's called an air gap. The website is actually loaded in a disposable container way up in the cloud. All that gets sent to the user is a safe, interactive video stream of the page. It means no malicious code ever touches the actual endpoint device. It's brilliant.
And the impact of this is just massive. Gartner actually predicts that companies using browser isolation can slash the number of endpoint compromises from web-based attacks by as much as 70%. It is an unbelievably effective tool for your highest-risk users and situations.
Okay, so we've secured DNS lookups and web traffic, and that covers a huge chunk of internet activity. But what about, well, everything else? All the non-web applications, the custom protocols. That is where our final layer, the cloud-delivered firewall, steps in.
The main job of the CDFW is to extend that security protection beyond just web traffic to all of your outbound connections. The way it works is by creating a secure IPsec tunnel from your network router or firewall up to the umbrella cloud. This lets you enforce consistent firewall rules for any application on any port, not just your standard web traffic on port 80 and 443. This last architecture diagram really ties it all together beautifully. All the traffic from your network gets sent through that tunnel to the umbrella cloud. Once it's there, it gets routed intelligently. Web traffic goes to the secure web gateway for that deep dive inspection, while all the other non-web traffic is handled by the cloud-delivered firewall. And just to be clear, this is way more than a simple port blocker. It works on multiple layers, from your basic IP and port rules all the way up to layer 7, where it can actually identify and control specific applications. It even has a full-blown intrusion prevention system, or IPS, which uses threat intelligence from the world-renowned Cisco Talos team to actively block exploits and attacks in real time. So, when you bring all of these layers together, the DNS security, the web gateway, the browser isolation, and the firewall, all into one single cloud service, you finally achieve the goal of a modern security architecture. You can deliver secure access to anyone, anywhere, move your security controls to the cloud edge where they belong, and make your whole business way more agile. And that's really the key question we want to leave you with. You know, the old network perimeter is a thing of the past, and work is happening everywhere now. The real challenge for all of us is how our security architecture is going to evolve to protect users in this new reality. Thanks so much for joining this explainer.